Welcome to the instructional video solving the fundamental trig identities on ck12.org. So we've gone through our subjects. We have found trigonometry, and we are looking at the first of our trigonometric identities. As always, these videos are focused on the adaptive practice. You see it's assigned in this class when I'm logged in. So we have that nice hint. We can jump directly to the practice from here, and this loads. So here, cosine of x times the tan of x for our fundamental trigonometric identities. Remember, tan is sine over cos. So if we multiply by cos, then we just get sine. The quotient identity for cotangent. That's the reciprocal of tangent. If tan is sine over cos, then cotangent is cos over sine. And according to the definition of cofunction identities, we want to look at angle A. Secant of 90 minus A is 1 over the cosine of 90 minus A. But if we think about cosine of 90 minus A, that's the opposite side of the triangle. So that's the same as the sine of A. So this one would be the same as cosecant A. So sine of 90 minus A is cosine of A, just like cosine of 90 minus A is sine of A. The same relationship holds true for secant and cosecant. Here we want to use trigonometric identities to simplify 2 sine theta plus cos theta squared plus sine theta minus 2 cos theta squared. So give me a moment while I open a whiteboard. Alright, I've now created a Limnu account, which is free. So let's take a look here. So we have a 2 sine theta plus cos theta. And 2 sine theta plus cos theta, we're going to square that. And then we have a sine theta minus 2 cos theta squared. We square this, we have a 4 sine squared theta plus 4 sine theta cos theta plus cos squared theta. I just want to double check that these were being added and not subtracted. Yes. Now here we have a sine squared theta minus 4 sine theta cos theta, and then plus 4 cos squared theta. Now our 4 sine theta cos theta terms cancel out. We are left with 5 sine squared theta plus 5 cos squared theta. If we factor out our common factor of 5, sine squared plus cos squared is 1. That's our Pythagorean identity. So we're left with a simple 5. This is one that we could have graphed as well. We could graph all 4 and see which ones match. Now, again, using trigonometric identities to simplify sine plus 2 cos. So let's move up. I think the pen on the fine tip is actually easier to read. So sine plus 2 cos. We are multiplying that by sine theta minus 2 cos. Minus 5 sine squared theta. So this is equal to a sine squared theta. We have a plus 2 sine theta cos theta minus 2 sine theta cos theta. Sorry about the interruption. That's a sine theta cos theta minus a 4 cos squared theta minus 5 sine squared theta. Again, our terms that are mixed cancel out. If we collect like terms, we have a negative 4 times cos squared theta plus sine squared theta. So the whole thing simplifies to negative 4. Again, graphing is possible. So if cosecant theta is a negative or is a 0.7, sine theta, right, would then be the reciprocal of that, 1 over 0.7, or 10 over 7. But the sine of negative theta makes it the negative sine of theta. So we're at a negative 10 over 7, or a negative 1.43. Yes, we have already achieved the mastery. We'll go to 10 as well. If cosine is 0.25, what is the secant of negative theta? Well, cosine is an even function. So cosine is 1 over secant, and secant is 1 over sine. So secant of negative theta is 1 over the cosine of negative theta, which is 1 over cos theta. 1 over 0.25 is 4. Now, use trigonometric identities to simplify this. We start with the difference of perfect squares. Sine plus cos times sine minus cos. That'll be sine squared minus cosine squared. Now, we subtract 2 sine squared. That's a negative sine squared minus cosine squared. We don't have any 2's anymore. That's a negative 1. We want to use trigonometric identities to simplify this. Our 2 cosecant plus 2 cotan times 2 cosecant minus 2 cotan. This is cosecant squared minus cotangent squared. And that's the whole thing is going to be times 2 squared. So cosecant squared minus cotangent squared is 1 over sine squared minus cos squared over sine squared. So we've multiplied this through. It is the Pythagorean identity. This thing will be 4. Now again, we'll have sine squared plus cos squared plus 2 sine theta, or 2 sine cos. And then sine squared plus cos squared minus 2 sine cos here. The cross terms cancel. So we have 2 sine squared plus 2 cos squared. That's 2. And that hits our 10 out of 10. So we've got 3 memory boost questions, which appear to be new and perhaps not even loading. Okay. Anyway, we can stop for now because we are done. We can even turn in the assignment. All right, and this completes the solutions for the fundamental trigonometric identities.